Welcome to this explainer. Look, today we're tackling something absolutely crucial together, the architectural complexities of MCP. Since AI integrations are practically becoming the backbone of modern enterprise infrastructure, understanding exactly how these intelligent agents hook into our private internal systems is not just important, it's paramount. Today, we're going to expose the unique vulnerabilities hiding inside these connections, and most importantly, we're going to build a strict, actionable blueprint for secure server development. Let's just dive right in.
Here is our quick roadmap for today. We'll start with MCP architecture and data flow, look at the expanding attack surface, break down the anatomy of MCP attacks, and wrap up with core security controls and the security minimum bar. All right, let's get moving.
So, Model Context Protocol, or MCP. As you likely know, it's the open standard defining exactly how our AI agents securely talk to external tools, APIs, and data sources in a highly standardized way. But conceptually, I want you to think of MCP servers as these heavily trafficked, really high-risk bridges. They're connecting incredibly capable AI assistants directly to your sensitive enterprise databases. Because of that massive delegated power, any structural weakness on this bridge has absolutely profound security implications for your entire network.
Let's actually trace a single JSON RPC message across this architecture, just to see where things can go off the rails. It happens in 4 distinct steps. First up, the AI host. That's where the request originates. Then, it passes through the client intermediary. Third, it hits the MCP server itself. And fourth, it finally executes against your external services, like your private databases or internal files. Understanding this exact flow is totally critical, because every single step there represents a doorway we have to actively guard. Because it turns out, attackers are already knocking.
Now, the security treatment you apply drastically contrasts depending on your deployment environment. For local MCP servers, keeping things in isolated subprocesses using STDIO, Unix sockets, or strictly binding to localhost, that's definitely the way to go. It keeps things neatly contained. But the second you move to remote MCP servers, static network trust goes completely out the window. Remote connections strictly require transport security, so TLS 1.2 or higher, plus dynamic identity verification using robust protocols like OAuth 2.1 or OIDC. You simply cannot treat these two environments the same way if you want to stay secure.
Which brings us to a really critical question. What actually happens when trust is implicitly granted to an AI agent? You see, MCP servers are often implicitly trusted by the very agents they serve. If the checkpoints on our architectural bridge are weak, well, this implicit trust quickly becomes our worst enemy. It allows a single compromised tool, or even just a rogue instruction, to silently redirect actions and endanger all your downstream systems without tripping a single alarm. It's a quiet but devastating threat.
To really grasp this danger, we got to recognize that every single hop in our data flow introduces a distinct localized attack surface. Up at the AI host layer, we're dealing with prompt injection, right? Hijacking the agent's core intent. Down at the client layer, the risk is unauthorized invocation, leading straight to privilege escalation. Moving over to the server, the major nightmares, data exfiltration, the silent theft of your sensitive data. And finally, at the external services layer, attackers are gunning for credential abuse to achieve lateral movement across the network. Every single layer needs highly specific interventions.
So how are attackers actually exploiting these surfaces? They're using some incredibly clever methods. A prime example is tool shadowing. This is where an attacker registers a malicious tool with the exact same name as a legitimate one, totally hijacking the agent's behavior before you even realize what's happening. There's also cross-agent contamination, where a compromised agent poisons shared memory to infect whole multi-agent pipelines. And man, we really have to watch out for supply chain rug pulls, where a trusted MCP package gets a backdoor added after a security audit. It's literally like handing someone your house keys and they change the locks while you're inside. Add in code injection and credential leakage, and it's a perfect storm.
Look, it turns out logical separation alone is simply not enough here. In multi-tenant MCP systems, if servers are executing code in a shared host environment without strict sandboxing, well, a malicious tenant could easily exhaust shared resources or even peek into the private process memory of others. To build something truly secure, we absolutely have to move from shared environments to strict compute isolation. We're talking dedicated containers or micro VMs to make cross-tenant data leakage structurally impossible. We need to build actual walls, not just draw lines on the floor.
This leads us to a massive golden rule for MCP architecture. Treat sessions as state, not identity. Relying on session IDs alone for authorization is incredibly dangerous. It's an open invite for identity impersonation, where a clever attacker tricks the MCP server into misusing a legitimate user's privileges to run unauthorized actions. That completely bypasses all your intended security constraints. We must always verify the actual execution context behind the session rather than blindly trusting a session token itself. Okay, so how do we actively defend against all these sophisticated threats? It really boils down to a few core security controls. First off, enforce schema-driven validation for every single input and output. Basically, systematically treat all data as untrusted. Second, issue short-lived, scoped tokens. Think minutes, not days. Third, explicit tool allow listing is huge. Adopting a deny-by-default posture gives you tremendous control. And perhaps most importantly, mandate a human in the loop. An AI agent should never, ever execute destructive actions without explicit human confirmation.
One control I really want to highlight is strict lifecycle management. It is totally non-negotiable. You've got to ensure deterministic cleanup. The exact second an MCP session terminates, disconnects, or times out, your system must violently and immediately flush all file handles, wipe temporary storage, and destroy any cache tokens. Residual data exposure has to be prevented by completely wiping all in-memory context right upon disconnect. Leaving that data lingering, it's just an open door for an exploit.
Before you even think about deploying an MCP integration into production, there is a strict minimum security bar you need to clear. For remote servers, robust authentication like OAuth 2.1 is an absolute must. You have to guarantee full isolation of users and execution contexts. Also, make sure your tools are cryptographically signed and version pinned, so their behavior is totally predictable. Schema validating every single JSON RPC message is just basic hygiene at this point. And lastly, ensure your hardened deployments are feeding audit logs straight into a continuous monitoring system to catch anomalies instantly.
As we start wrapping up this explainer, the big takeaway is that proactive defense is absolutely essential. Bolting security onto an MCP deployment after the fact, it will fail. Because MCP servers inherently operate with delegated permissions and complex toolchains, things like the principle of least privilege, rigorous input validation, and continuous monitoring, they have to be architected into the very DNA of your deployment from day one. You just can't treat AI security as an afterthought.
So I want to leave you with a critical question to reflect on today. Is your MCP infrastructure a heavily guarded bridge, or is it an open door to your enterprise data? I really challenge you to review your own AI integrations today. Verify those isolation protocols, check your tool allow lists, and just make sure your AI agents aren't silently holding the unsecured keys to the kingdom. Thanks so much for unpacking this complex topic with me. Until next time, stay secure.